All right. We are not able to get started unless someone volunteers to be a note taker. Who wants to be a note taker? Okay, we would like to start, but we still do need a note taker. No one wants to be a note taker, but we need someone to be a note taker. Cannot.
How helpful is this?
Okay, what's going on? Okay, this works. Okay, welcome all. We're about to start Mboned, and now that we have a few other folks in, looks like we have some prospective note takers who have walked in. Who would like to be the note taker? We will begin.
Coercion. Oh,
Okay.
fantastic.
Great.
Yeah,
All right,
please.
that's all we ask
And-
for. You don't just try.
Yeah, don't be afraid of shouting at people to get their names and everything.
The rest don't do. Only try. Yeah, just email it to us when you're done. Okay, let's get started. So, welcome to the Mboned portion of today's meeting. Pim will be following us.
Water.
Yes, sure. Let's start with, as we do always, the note well. Please note the new note well. Okay, noted. Agenda. We'll start with a few working group items. Mike will be speaking about his data center deployment draft, giving an update on that. Tim will be talking about the deprecate ASM for interdomain deployments draft. We have a very special presentation on from William Zhang. He is a high school student from Thomas Jefferson High School. And for his senior project, he's been deploying and operating an AMT, a public AMT relay that's connected to I2 and the commodity internet. And he's going to talk about his experiences so far. Not sure if we've ever had a high school student speak at IETF, so this might be a first, maybe not, I don't know. And then Sandy will give an update on the Yang models, and Mike and Charlie will talk about the recently adopted Wi-Fi draft. Anything to add? Any complaints? Anyone want to bash the agenda? Okay. Moving along. Status of the active working group drafts. So first, the interdomain peering draft had been around for a long time, and since the last IETF, it has finally become an RFC. So congratulations to Percy and team. 8313. Currently in last call, or currently at IESG, is the M-Trace draft. While it's been there, it has there's been a number of good, helpful comments and discuss issues. Recently, there was some pretty substantive security issues brought up, and the authors late last week provided some updates to the draft in response to those discuss items. Do we have either any of the Hitoshi or Kerry in the room? No. So their comments somewhat speak for themselves last week. Hopefully this should be enough to clear up the discuss issues, and hopefully we can move that along. Since last IETF, the Wi-Fi problems draft was adopted by the working group, and I believe it was merged with another draft. Mike and Charlie are going to provide updates on that. And there's the data center deployment draft. Mike's going to talk about that today. Other drafts that have not yet been adopted is the Yang models draft. Sandy will give us an update, but essentially he took that since last meeting. He took that to the Yang doctors, and the Yang doctors did give some comments and helpful feedback, and he has updated the draft. Or I'm sorry, she. And the models draft was went for adoption call. Didn't quite get enough support for adoption. However, there was a little bit of confusion as to what it was saying. It's been trimmed down to just focus on the deprecation of ASM, less so on models. And Tim's going to provide an update on that and possibly see if we're ready for adoption after that. Okay, so I noticed William has joined. Mike, if you don't mind, William has a bus to catch for school. Literally. William, are you ready to present?
He's already in school.
He is. He's on the Meet Echo.
I need to get active soon as well.
Okay. All right. Okay, Tim, why don't you come up then? Mike, you're getting bumped by two people. Sorry. But you got to stay here the whole time, so. Yes, and stand in the red box. Pink box.
Right, okay, so it says on, but it's in the on position. And now the red lights come on. Turn it off and on. But it's still. Can you hear me? Oh, of course, it's remote people.
Yeah, I'll ping you.
And
Yes, sir.
Rock and roll.
God, that's heavy. It's much heavier than it looks, this. Okay, so talking about, as the chair said, we had originally a draft, the multicast models draft, and we've now adjusted that into a new focus. So what we're going to talk about now is deprecating ASM for interdomain multicast. We've got 3 authors there from the previous version, and Torlis is also potentially coming on board as an author, but unfortunately he can't be here because he's over chairing Anima at the moment. So next slide.
So yeah, the original draft was about multicast service models, and it was quite long and had lots of sort of messages in it. And the feedback we've got from the past two IETF meetings is basically to focus on one of the key messages, which is about promoting the use of SSM and deprecating complementary deprecation of ASM into domain. So we've posted a new draft as a 0.0 covering that topic. Next slide. So a reminder of one of the early drivers for this, or one of the drivers for this work. There's obviously a lot of others out there. But there's a proposal made by David Farmer on the Internet 2 list, which sort of captures the thrust of what operators are saying, which is that running interdomain ASM is a non-trivial task. It's very tricky to troubleshoot. There's lots of components to it. It's the need for MSDP, which is still an experimental protocol as far as the IETF is concerned. So the idea over there in Internet 2 is they just wanted to drop to using SSM for interdomain stuff. And I think the question there was they were asking on their list as to what people thought of that, and there was generally support for doing so. Next slide. So the new draft, the structure of it is cut down, right down the model stuff is pretty much all gone. There's literally a page on the difference between ASM and SSM, brief discussion of their deployment, how they're deployed, and then into the advantages of SSM. And the bulk of the document now are the recommendations for what we should do and what we actually mean when we say deprecate interdomain ASM, because you could interpret that in many ways, and there's lots of side questions where we kind of need to nail down what we mean and have agreement on that. It's like one of these torture things where they get you to hold a brick out at arm's length. Come on. Next slide.
Keeps the presentations focused.
So this is the abstract right at the start. So I guess if you want to quickly read that, and if you've got any violent disagreement with what we say here as the highest level statement in the abstract, then come to the microphone. Come to this microphone. I don't know. Stand up and express your objections. The little bit on blue on the end is the bit that Torlis has added. So if we bring Torlis online, we've got a slightly updated version that we'll post. But it's basically saying recommend the deprecation of ASM interdomain, recommends use of SSM for interdomain, and therefore that hosts and routers involved in interdomain applications must fully support SSM. But it also, and this is part of the pushback we had from adopting it before, makes it very clear that we're not saying, we're not precluding continued use of ASM within a local domain for intradomain use. Next slide. So what we mean by deprecating ASM for interdomain, there's a section 4.1 on that. So as I said, it's implicitly that all the hosts and routers are fully supporting SSM. Thanks to Percy in the room. He's been through this mammoth journey of publishing RFC 8313 on BCP for interdomain SSM. So that's a useful thing that we can now refer to for this. And importantly, this applies both to MSDP as a method for doing interdomain ASM, but also embedded RP. So I've kind of got this fond attachment in a way for embedded RP, but it's kind of a victim in this. We're saying if we are going to deprecate interdomain ASM, we mean for both v4 and v6 with the tools that are there for that. It also recommends against the use of PIM-SM with an RP where the multicast tunnels are used between domains. And something that Torlis suggested adding was a more inclusive interpretation, which might include devices under a different operator control where the multicast is sourced from a different operator. And the important thing is that we're not proposing to make MSDP historic. And again, that fits with not precluding the use of ASM within a single organizational domain STIG. You might as well come up here because no one will hear you. You can hold this for a bit. You need
Did you call
you need the remote people to hear you.
This I can help you hold it.
Yes.
Okay, this is Stig. So I was just wondering, do you deprecate embedded RP completely or just use it for intradomain?
So use of it for interdomain. So maybe on the last bullet, it should say not making MSDP or embedded RP historic. They're both. If you want to use that within your own domain, that's fine. So for example, at the university I was previously at, we used embedded RP for IPTV stuff.
Yeah, I think it's no different than PIM, right? We're not deprecating PIM ASM either. We're just saying don't use it for interdomain.
Exactly. So everyone's happy generally with the points there. Good. Next slide. And the implication here is network support for IGMPv3 and MLDV2. So again, we're recommending that all hosts and routers supporting multicast and also any security appliances handling it support both protocols. I'm involved in the BIS version of RFC 6434, the IPv6 node requirements, and we've made MLDV2 a must for hosts there where it previously wasn't. So that's kind of complementary to that. And also, if you've got things like snooping functions, they must support both protocols as well. Seems uncontroversial. Good. Next slide. So yeah, the next topic is kind of then building the application support for SSM. So applications, we would prefer them to use SSM and operate correctly in an SSM environment, and obviously triggering the IGMP and IMLD messages as required. We do note. Oh, oh, please. Yeah, so we got a note in there about the different programming languages and their support, and the main gap at the moment seems to be in WebSocket. So we've just noted that in the draft, whether we leave it in there in the final version or not.
I'm gonna be kind to you and give you this that actually works, so you don't.
Thank you very much.
Very good.
Minutes for thanks for the. It's definitely working.
Early
Good.
morning workout.
His arm is cooked.
Where was I? Oh, yes. So, yeah, in feasible, what we would like to recommend is that applications use SSM, even if they're in, even if they might be. We recommend that applications use SSM, even if they're in that intradomain environment where ASM is supported. The idea then is as more applications get deployed that use SSM rather than ASM, you may be able to prune back the way that multicast is used within your site. So you may have an environment that supports ASM applications and all the MSTP and all the other relative complexities of that. But if you slowly introduce more and more SSM applications, you can move to a point where you're only using SSM. So this fits in again with the not precluding use of ASM, but we're saying you kind of want to move to a point where that's used less and less, I think. And yeah, the thing in bold at the bottom, we're sort of implicitly pushing the source discovery to something that isn't the network layer, above the network layer, some relative out-of-band thing. So there's still the complexity of discovering the sources somewhere, it's just not in the network. Next slide. We've noted a couple of things that might be, or we think would be good things for the IETF to work on, or the Mboned, or whichever group it would be in. One would be guidance on converting ASM applications to SSM. And the other would be best practice for SSM applications in some greenfield design or greenfield deployment area. And the other would be a mapping mechanism to translate star Gs to SGs. Now, different vendors have different ways of doing it. I know Cisco and Juniper have mechanisms for that, and they've been around for a long time. They're not really standardized methods, though. So the IETF perhaps defining a consistent and common way of doing that might be useful. But we would emphasize that it should be viewed as an interim solution, not something that would be there long term. But as hinted in very faint font there, interim things do tend to stay around for some time. So, no one coming to the mic, that's kind of good in a way, I suppose. Next slide. I mentioned this last time, actually. In theory, if you're deprecating ASM interdomain, you might make an argument to filter out ASM traffic that you see interdomain, but our view is that you shouldn't be doing that because if you have this mapping mechanism in place, you'd kind of preclude that from working potentially. So that might be something that the MOD might recommend in the future, but at this stage, we wouldn't say that you should do that. Next slide. And again, yes, emphasizing we're not precluding use of intradomain. Obviously, it's intradomain ASM is still very common in enterprises and campuses today. And there's some text I've cut and pasted from the document there to emphasize that. So if you want to have a quick glance at that and see whether that's something you agree with, that's fine. If you object, maybe come to the mic now. Okay, next slide. So that's basically a sort of a summary of what's now in the draft, and you can see the much clearer focus on deprecation of ASM, not precluding use of inter-domain ASM, not precluding intra-domain ASM, but also encouraging deployment of SSM everywhere, essentially. So that's it. Are there any comments, feedback? Is it something that you want to adopt now as a working group item now it's been reshaped? Any strong feelings on it?
Just Mike McBride, just a quick question. What is the state of interdomain multicast? What's the state of interdomain multicast?
Well, that's a very good question.
ASM. Is it?
How much is actually in use?
Yes.
We might be able to answer that question a little bit better in the next presentation.
It's a Stig. It's not just one comment on that, and maybe for this draft too. It could be worth maybe separating between interdomain as in random people can talk to each other, and interdomain in the sense that you have, say, a content provider peering with an ISP, right? So I don't know in this draft if you want to call that out in particular, whether this applies to just sort of two domains that are, have a close relationship to each other, or if it's really just interdomain as sort of random people.
Okay, that could be a good point to include. Hopefully that's been minuted.
Yeah, Michael, I think we discussed this here before that it's very common that you have like a head end or something that one entity is running, and like for TV channels and just injecting all the channels.
Yeah.
I don't really know if that should be called interdomain at all. In the it's not two AES numbers necessarily speaking to each other. So I don't know how much.
So yeah, maybe more having a little section discussing what we actually mean by interdomain.
Yeah, it should be like we're actually talking now about two different ISPs basically over the internet or something, trying to do this, and that shouldn't be done. But I don't know how much that I don't want the draft to become huge either. But yeah, we could have a little bit of text on that.
I think I remember looking at that Internet 2 thread, and there were things on there like the NRN essentially offering to run RP services for the sites and all the traffic hairpinning around, and and the universities don't necessarily have any relationship with each other. They kind of have a relationship with the NRN, but it's the NRN saying this is unnecessary complexity for us to run. We believe we're not seeing much ASM interdomain traffic. We would like to see things SSM for our simplification of our operations.
Yeah, and I mean, we're not the internet police either, so we can't stop people from doing things. It's just saying,
this is just I presume this would be a BCP, which you can follow or not, of course.
At least until we get our police force up and working, and then we can start knocking heads.
There's a draft on that, right?
Yeah. So just a sign of hands. Who has read the most recent version of the draft, this updated version?
Yes, it is. It was posted before the cutoff. It's just not called multicast models. It's called a new name, and I've not with the tallest comments. No, sorry.
Okay.
But those I've gone through that with a fine-tooth comb. He's basically put his sort of area experience into it and added some useful little comments. He's not changed the thrust of anything at all there, except that comment about, and it's what you raised, Mikhail, about what's interdomain. Is it the provider and the set-top box operator? Is it? And I think on the feedback, we would look at defining what we mean by interdomain a bit more cleanly. But yes, the 00 is what's out there now.
Great. So it looks like two people have raised their hands. Of the two, do you think it's ready for, would you support adoption? Or how about other folks in the room who haven't read it but have been paying attention for the last 10 minutes?
Who's been paying attention? Hands up.
Yeah, so the other folks in the room, just a show of hands, who would support, who thinks that this would support adoption for this, just a non-binding. All right, looks like about 7 or 8 or so. Anybody would be opposed to it? Okay, 0.
It's a landslide.
Yeah, can't get more agreement than that. All right, so we'll take it to the list. It sounds
Okay.
like it's ready for an adoption call on
Right.
this latest rev. Any thoughts about your second bullet? What should be done? Is this another document? Anybody else have comments or thoughts?
I think at the moment we would just park the content that was basically all being thrown out until this is done and dusted. There may be shifts in opinion on this, so get this one done and then move on from there. But there's the other two potential drafts that we could start working on now about converting ASM applications to SSM and the mapping thing. Maybe discuss those on the list.
Yeah. Anybody have any comments on these three things? Either the old models or the BCP to convert or the documenting mapping mechanisms?
Rob Evans, just do we need this protocol mapping mechanism if we're deprecating into the main ASM? What are the applications we're supporting? It seems like a lot of work for what might be a very limited use. And whether it will hang around in the future to be a millstone around our necks.
Yeah, certainly I hinted at the millstone thing with a very faint text on that slide. I mean, it would enable applications that for some reason can only work ASM to actually work into domain, because they would then be able to effectively talk SSM through the mapping mechanism.
Yeah, Jake Holland, the other answer I've heard to that is there's legacy hardware that does IGMP snooping, but not v3 SSM. And so sometimes you can't get forwarding without through your access network or your LAN without the application using v2.
I mean, it's essentially a side thing. We can progress this BCP without that mapping mechanism, but what would be interesting to hear are people with applications or places where if the BCP advances, they will say, but wait, I now can't do this because all my stuff only talks ASM, only talks IGMP v2 and MLD v1, for example. Hopefully there aren't many of those, but
Michael Abramson. So I don't know if we put text in there, but we had that discussion about supporting MLD v3 doesn't mean you're supporting S, G joins. Do we actually have text that states that you should support S, G joins over MLD v3?
MLD v3.
MLD v2. Sorry, I got the IGMP. But like the source, I mean, you can do star, G joins over IGMP.
Oh, right.
And
Yes.
MLD v3.
So I think it does say.
Because the point is S, G joins, not the specific
Yes.
version that actually
Yeah,
supports it.
that's worth minuting, and we should clarify that. Yeah.
Yeah, because this is it's thought about the snooping functionality there as well. I mean, it also needs to support that part.
Yeah, that's a good point.
But because I've run into vendor equipment that did support MLD v2, but did not support S, G joins.
Okay.
Just quick comments because we're running low on time. So.
Okay, so Stig. So I think, even though we try to help people port their applications to SSM, which we should, I like the idea of this draft at the bottom there. It will take a while for, to get rid of ASM applications.
Oh, yes, and they may never go away.
So it is definitely useful to have those mapping mechanisms there, but we need to document it in the IETF. I'm not quite sure, but yeah, might be okay to do.
I remember your mapping mechanism from about 15
The
years
thing though
ago.
is if we actually sort of like standardize, say everyone should support this mapping mechanism, then there might be less incentive to port applications to SSM.
Yeah, that's the logic by which 6XS got rid of their tunnel broker, isn't it? It's that school of thought.
Yeah.
Right, Jake Holland. On a similar point, are there examples of BCPs about converting applications that we have to work from?
Not that I'm aware of. That's why there's a suggestion that we might want to write one.
Okay. I might be able to help on that if it seems worthwhile.
I don't think it's going to be a huge document, but
Okay, good.
just say it's a gap, I think, in Mboned's arsenal at the moment.
Yeah, these seem like good comments. Thanks.
Great.
Thank you. So let's take those comments to the list. We'll take the adoption call to the list. Okay, William on MeetEcho. Are you ready to go?
Yep. Can you hear me?
Okay. All right, William. Are you able to project the slides, or do we project the slides for him? Anybody done Meet Echo before? William, does Meet Echo allow you to bring the slide up, or is it?
I don't think so.
Okay, all right. Then I will bring your slide up here.
You can also use the PowerPoint that I sent you, or
I have. Hide the sidebar. There we go. I did not update with the latest, so this is what you sent yesterday.
all right.
Okay, you are ready to go.
All right, so hello everyone. My name is William Zhang. I'm a senior at Thomas Jefferson High School in Alexandria, commonly more known as TJ. And my project today is my research project, a public AMT relay between Internet 2 and the commodity internet. So next slide. I'm not seeing the slides for some reason. Oh, there we go. So my project involves deploying the MX80 as a public AMT relay. I have the support of the school's network administrator, which is Mr. Maraska, Peter Maraska, and Lenny Giuliano, of course. And they've been helping me set this up. And one of the things I'm trying to do is catalog and curate what's already there on the Mboned. So for multicast content, we want to provide like an easy way for internet end users to get that content. And to do that, I needed to look at, what AMT gateways we already have. And I also needed to figure out how to provide simple guidance to content owners to, provide more multicast content. So next slide. And the goals I'm trying to get here are, I want to deliver multicast content from Internet 2 to unicast only receivers on the commodity internet. And this is a unicast only administrative domain to a multicast enabled administrative domain model, described in 8313 section 3.4. So if you want to look at this model, I guess you can read that. And another goal of my project is to gain experience, prove viability, and develop best practices for running the relay. And yeah, so next slide. For some reason, the slides keep going black when you go forward for some reason.
Yeah, it takes a little while for them to come up.
Yeah. So you can see here, this is what our setup looks like. So we at TJ are special because we have a 10 gig peer-to-peer link to Virginia Tech, and we get native multicast connectivity to Internet 2 via that connection. So we're able to receive native multicast from Internet 2. As many of you know, Internet 2 contains a lot of Mboned. And yeah, so our AMT relay sits on the TJ border network, and we can receive native multicast video or other content from Internet 2 and relay building an AMT tunnel to the commodity internet to interested receivers via Virginia Tech. So we have a 10 gig link to Virginia Tech and a 1 gig link to the commodity internet. And so the significance of this is that we potentially have the first public AMT relay on the Mboned. And yeah, I think that's pretty cool. I guess I'll just bring up my own slides so I don't have to wait. Sorry.
It's up.
Oh yeah, I got it. So if you don't have any content, there's no point in building an AMT relay or having AMT gateway. So we need to look at what content we have already on Internet 2. Internet 2 actually does provide a nice service called the Internet 2 Looking Glass. That's hosted by Indiana University. And it lets you run commands on Internet 2 routers on the web interface. And I'm interested in looking at the output of show multicast route detail, but there are too many routers to do by hand. There's like at least 50. So I just wrote a Python script and I looked at the request endpoint that this form was sending to, and I parsed all the responses from each router, and I just reformatted into stuff that that's useful to me. And you can look at the code that I used here on GitHub. So next slide. So my methodology for collecting data, I needed to filter out anything that didn't have a packet rate more than five packets per second because we're looking for interesting content here, and anything with less than that is probably not very interesting. And the other problem with this is that any output at any given time isn't actually representative of what that source is, because if you don't have any interested receivers, a source won't necessarily show up in the output. So to combat this, I actually just ran my script as a cron job for every 2 hours for over a month. So I collected like a couple hundred logs. And at the end, when I have all the logs, I just wrote another script to just sort them and figure out who is operating these sources via who is data. So next slide.
And just to add, the 5 packets per second was selected somewhat arbitrarily as William said, to find interesting content. There's a lot of, there's hundreds of streams out there that, had less than 2 packets per second. Most likely those were beacons. So we weren't interested in seeing beacons. So to kind of filter that out, we just used 5 packets per second as a threshold.
Yep. So you can look at the raw data we got here. This is on GitHub too. I also included another link with the results with the who is included. And so overall, you can see that we have 119 unique multicast sources and 40 unique multicast groups on Internet 2. And the 3 most interesting ones that I found are this first one, which we've been actually actively using to test. This one is George Mason, but as far as I can tell, it's also National Science Foundation TV. I don't know if there's an association there, but yeah. And also we can see the Red Iris, some company in Spain, and then we also have EUMETSAT with the highest packet rate by far. So all 3 of these I've tested out, and they're all video with audio. But yeah, I guess that's good. Next slide. So with this content, obviously, if you're going to deliver it to unicast-only networks, you're going to need an ANC gateway. And I've been looking at what's already out there for gateway implementations, and the first one I've seen was the UTJS implementation for VLC. You can look at it at this link here. It works, but it's outdated. It's on VLC like 0.9, and it's also Windows only. But it's what I found to work the best so far. It's a little bit buggy. Sometimes it'll crash. I'm not sure why. But yeah. Another implementation I looked at was UPipe's work. They actually made this really cool demo with NACL, native client. It lets you run native code in the browser. It actually apparently works, but I haven't actually been able to get it to work. I've been told by the UPipe guys that it works, but neither me nor Lenny have gotten it working. Another big problem with this is that it's using NACL. It's Chrome specific, and it's actually no longer supported by Google. They disbanded the team last year. and it's also SSM only, but that doesn't seem like a big problem based on the previous presentation, since we're deprecating ASM for interdomain. And finally, I also actually know I have more, but I looked at UT Dallas's reference implementation. I think Concordia did some work on that too. It's AMT GWD, it's Unix only. I've been able to get it to compile and run, but it's bundled with gproxy. It's an IGMP v3 proxy implementation. I haven't been able to get that to compile, so I'm not sure whether it works completely or not. So next slide. So I also looked at Greg Baumgartner's work with JS4MS, Java SDK for multicast services. I actually made my own fork. I just made a couple changes to try to make it work, but the major problem with it is that it's missing the documentation. And Greg also told me that he used a self-setting certificate, so I can't actually run JNLP once I've built it. So that's a big barrier to using that. But I've also, there's also a very promising implementation by Jake, who I think is here. And I also forked it. I just changed 2 lines to get it to work on my end. And I got it to compile and run. It also needs an IGMP v3 proxy, but it uses mecproxy, which is actively developed. I don't actually know if you can use mecproxy with the UT Dallas / Concordia implementation. So I haven't tried that quite yet. I also haven't gotten around to actually testing this one fully either. And so finally, we also have Cisco SSM AMT tools. This is, as far as I can tell, the only available AMT library for like embedded AMT library. So it's useful for like building your own standalone thing. It has pretty decent documentation as far as I can tell. Like they document every function, what it does, how to use it. So that's pretty good, and that makes things easy. So next slide. So with all these gateway implementations out there, there's not really a clear, best solution. Obviously, the VLC mentioned earlier does work, but it's severely outdated and it's Windows and it's buggy. So the logical step here would be to integrate it into a new version of VLC and also port it to all the other platforms. VLC, as many of you know, is pretty widely supported in the industry. And it's also, it's cross-platform, but I'd assume you have to write specific code for each platform anyways. But another idea I've been looking at is WebAssembly. So WebAssembly, if you guys don't know, it's a new technology. It's meant to replace NACL, but it's also cross-platform. It's supported by Google, Microsoft, Mozilla on all of their browsers. And one of my ideas is to build an in-browser implementation similar to what UPipe did with their NACL demo, but obviously with WebAssembly that's actively supported. But it's very new. I think it really only got, accepted last year as a standard. So there's not really that much out there so far, but yeah, if anyone has any ideas on how to do this, I greatly appreciate the help. And next slide.
One more slide.
And finally, we also have, you can try out our public AMT relay. You can download the VLC with AMT gateway implementation in it from this link, and just follow these instructions, and you can try out the source that we showed on the other slide. So thanks for listening, I guess.
Hi, William. There is a question.
Yep.
Hi, Jay Collin. So,
Yep. Nice to meet you.
yeah, you too. Thank you. If you go back one slide there. Yeah, so the WebAssembly, I've also looked at this. The problem right now is that there's no UDP support. So it would need yeah. You're gonna have a problem with that. There are a couple of workarounds proposed. A good direction to look if you want to pursue this would be there was a WebRTC data channel standalone hackathon project this last hackathon. So you might want to check into that as a wrapper for UDP if you're desperate enough, or you might look into getting.
Right now, I don't have any experience with WebAssembly. I mean, I was just looking at it. I'm not really sure where to start with that.
Yeah, so I would just recommend that this WebAssembly idea is going to be a challenge for the moment. And thanks, this is very interesting. Appreciate getting it all together.
Yep, thank you.
Hi, Lucas Pardue, BBC R&D. So I was also at the hackathon working with Jake, and part of that was to try and get some of our multicast quick video distribution demonstrated in a web browser. So we looked at some of this for not so much the AMT side of things, but on deserializing quick packets within the web browser. So we use the mscripting tool to take a C++ based quick deserializer library and get that converted into WebAssembly, and spotted many issues along the way. Threading's a big one there, and there's lots of gaps between, say, depending on how you want to implement this as a web app, certain capabilities are not available in things like service workers, etc. So and yeah, you can't deliver things UDP multicast into that context. So rather than WebRTC, we chose WebSockets as something a little bit more straightforward. So we were able to demonstrate some of that at the hackathon and presented some slides on that are on the public GitHub repo. So you might want to have a look at that if interested.
Thank you.
Hi, it's Rob Evans. I just going back to the sources. I was wondering, as well as scraping active sources, did you have a look to see if anyone was still advertising things in SAP STP to get the source SCG for that and try joining those?
Lenny, do you want to handle that one?
Yeah, I don't think we looked at SAP or SDP. We were just trying to look at what's on the actual routers and to see what people are joining. But yeah, that's a thought. I'm not sure what applications still. Any applications you recommend that still have, I don't know, SDR?
No, I was just wondering if there was some legacy stuff there around and I might still be using it. The other thing is just for information.
There is traffic on the SAP group, so somebody's using it.
And just for information, Redois is the Spanish RNA network, is the equivalent of Internet 2 in Spain.
I see. Okay.
EUMETSAT, that's a fairly interesting project. It was set up for distribution of meteorological data that comes in by satellite into Germany and is spread out to certainly the European Met agencies. I'm surprised to see it popping up on a Internet 2.
Yeah, they actually, EUMETSAT actually has their website, and it's on purpose. It's a service they offer to folks who are connected to the Mboned or the I2 networks, and you can join that content.
Yeah, I mean, in parallel to setting up EUMETSAT, we also set up a whole bunch of measurement infrastructure along with it. So each EUMETSAT official point has a beacon and is a private beacon group. So it was set up as a only maybe 3-4 years ago, maybe a bit more, group with an measurement infrastructure around it as well. So
yeah, the interesting thing about EUMETSAT is they're the only ones that seems to be using SSM right now, and it's a pretty high bit rate. Yeah, so Greg, Mike, this kind of answers your question as to what is the state of the Mboned today. There's stuff out there, not a lot. one of the things that was disappointing was the state of the AMT gateway implementations. A lot of the work on AMT gateways has been Unix based with the plans to stick it into routers. If we remember, the original purpose of AMT was for end users, with their laptops or, smartphones, or this is before smartphones. But the goal of AMT is to bypass, have end users access multicast content. So the gateway implementations that exist today don't really, we're struggling to get them to facilitate that model. So that's a little disappointing. That's a little bit outside, well, it's well outside my expertise in working with William. So William and I would certainly welcome any assistance from folks who would like to help the VLC idea, since VLC is so widely deployed and it's available on many platforms. Updating VLC with AMT functionality would be wonderful. We're not quite sure where to get started, so if anybody knows anyone who has ever done any VLC development, we welcome guidance. Jake.
Hi, Jake. This one more suggestion of AMT resources. There's a Cisco CSR 1000V virtual image you can download that has AMT gateway support built in. And then one last question about the data here. I guess I can check offline if you don't know offhand, but do you have it, does it say whether these are SSM, whether there are RPs for the groups? Do we know are these joinable via SSM or ASM at the moment with the interdomain?
I believe the George Mason one is ASM, but I'm not completely sure.
I think the EU METSAT is pretty much the only SSM stuff. There's not a lot of 232 addresses. The others, the non-232 addresses, I would assume does have RP mappings. If you look at the MSDP SAs, there's over 2,000 MSDP SAs in the global cache. So
the 239s, I think, could be either way, correct? The glob can be sort of done.
239 shouldn't be appearing. 239 is administratively scoped.
Yeah. Okay.
So it shouldn't be there, but I think there might have been some stuff. All right. Thank you very much, William. Great work.
Yep.
All right. Okay, next up, why don't we bring Sandy up, and then Mike, you can finish with your last two. Sure, come on down. Yeah, we're gonna have to keep this quick to about 5 to 10, 5 minutes. Can you do? Okay.
Good morning, everyone. I'm Zhen Zhang from ZTE. You can call me Sandy. This presentation is for multicast young model. We had presented it for many times. Today we will make a brief introduction of the update of this draft. In this draft, we also have co-author Yin from China Unicom. Let's see the brief update of this draft. According to Young Doctor's suggestion, we changed the draft name from information model to Young model because information model has special meaning in some other SDOS, such as the ONF or other organization. So we changed the name to avoid confusion. And next we do some next, please. Sorry. So, and we do some writing improves according to Young Doctor's suggestion. So the main content of the model is unchanged, but we add more description to make it more clear. And also we add some notifications. It's still the modification of this draft. Somebody has seen it, saw it many times. So we just introduced it briefly. So this draft, this model is stand at a high level to take advantage of the existing multicast protocol young models to implement the multicast service. Next. Let's see this page. This is the brief introduction of Open Daylight organization. Because Open Daylight provides a model-driven platform to implement the several services, includes L3VPN and the other functions. So we can use the platform to verify our model. Next. So this is the project in Open Daylight. You can get the more information from this link. The project is driven by two young models. The first one is the multicast model defined here, and the other is pure protocol young data model. So this model has been verified in this project, and the project has been released in current version of Open Daylight. So this model is feasible and practicable. We also provide a UML-like class diagram to make it more clear. In this diagram, we just move out the multicast keys to make it more clear, so you can understand it very well. Yes. It's still the content of this model. It's remain unchanged. We have 3 layers in the model. Next. So we know that the overlay, underlay, and the transport lay always may remain unchanged this type. We just add some notifications for it. So we until now we add some node down restart event and the module loaded or unloaded events for it. So that's all. It seems like it has been adopted since last meeting, right? Appreciate it if it is.
Oh yeah, we're ready for the call, I think. So a question, just a quick show of hands. Who has read the updated, the most recent one? Okay. And another 2 hands. Other folks in the room, it seemed like last time, and there was support for adoption pending comments back from the Yang doctors. We did get comments back from the Yang doctors. You updated it based on that feedback. Feedback from the room, folks who would support adoption. Any hands? Okay, it's about 5, 6. Anybody oppose adoption of this doc? Okay, 0. That's a good sign. So we can take that to the list.
I just wanted to say thanks. This is one of the more readable Yang models that I've encountered yet, and I appreciate your efforts to make that happen. I hope that your techniques are adopted widely.
Thank you, Jake.
Great. Cool. So we'll take that to the list. Thank you.
Thank you. Thank you.
All right, Mike, you're up. You can take us home.
Actually, Charlie's going to take us.
Okay.
All right, so I'm not going to actually go through my slides. If you can just bring up the original slide, the cover slide. I'm panicking a bit, just as for the PIM side, we may have to cut a presentation or two. So let me just state that there is this draft. We've had it for several years now. I was encouraged to resurrect it, and I did. It's a draft that kind of spawned off from ARMD working group, which is now concluded. That working group was address resolution for massive numbers of devices. And the idea is, in our draft is to look at the use of multicast in the data center as a use case type of a draft. And so it's been updated. There's been changes in data center architecture over the last few years since this draft was created. It'd be good to get some feedback. I would love to have a co-author or 2. So if anybody's interested, it's a already working group draft. You get an easy name on a draft if you want. And I'd love to work with someone to to see how we can maybe update it with most relevant information on the use of multicast in the data center. And with that, let's go to Charlie.
Okay, great. So yeah, this is a really good draft, and love to see folks. Love to see this draft advance and progress. Blue sheets, please sign the blue sheets.
Do we not sign the blue?
Okay. When it comes back. All right, 15 minutes. It's half and half, or what? Pim, how long?
We said an hour and a half. We're already
Oh,
screwed.
okay.
Just because all right, we'll figure it out.
Okay, well, I'm Charlie Perkins, and thank you for this group for adopting this draft. It was adopted, and Mike and I had worked on the draft some years ago, and as Mike said, it was resurrected. But also, in parallel, a draft had been done. Oh, next slide, please. I'll just go through it in order. So basically, the reason why this draft is interesting to Mboned, and this is a development from the previous presentation that Mike made, but basically, Mboned is the place where people take care of the deployment of multicast technology, and this draft that I'll be discussing is all about the deployment and what's going on. So we want to have awareness of multicast over wireless and Wi-Fi, and make sure that the practice is improved so that we can really get better performance and provide feedback to the other working groups. And this may be actually the most important thing, because the way IPv6 was designed was not, let's say, particularly careful about how it would affect over over wireless. Next slide, please. So the issues are that for multicast over wireless ends up really being constrained by the slowest local recipient, and that means that it can be drastically slower than unicast. And since it's slower, it also occupies the medium for longer and increases the amount of interference. And since also it needs to be multicast to be received by the most distant local receiver, that means it could require higher power. And all in all, it is not uncommon for this to generate hundreds of times as much interference, and actually hundreds of times slower performance, pretty much for the same reasons. Another factor that's pretty important is that the reliability of multicast can be a lot less than unicast. And there's several reasons for this, but basically for 802.11 at least, all the manufacturers have been super careful to optimize for unicast so they can get good performance that way. And multicast is simply not considered as important up until now. And in particular, you can commonly you can get acknowledgments for unicast, but the multicast at layer 2 is not acknowledged. So IPv6 neighbor discovery is based on multicast design, and it ends up saturating the link. And that actually has a sort of a back pressure effect as well on the wired parts of the link if you have Wi-Fi and wired links in the same subnet. And so that means that some apps like Bonjour, as an example, saturate. And these problems are not likely to be fixed anytime soon. I mentioned that there was a parallel effort. An int area had been submitted, and this was actually another document. I'll show this one here. It had co-authors from Dorothy Stanley, J.C. Zuniga, and is Warren here? This is his group. So anyway, so we got together and put together a lot of text to describe the problem and some workarounds and some solutions and what had been noticed at conferences like IETF. So Dorothy in IEEE, she's the chair of 802.11 now as of last week or 2 weeks ago. She made a presentation in 802.11, and this stands for 2015. So it was a couple or 3 years ago, but there was a concerted effort in .11 to make awareness of these problems. And then that presentation was brought in int area, and Dan Harkett made a presentation from that. And then subsequent to that, we got together and made a draft, submitted it to int area. And as I'll mention in a couple of minutes, it was pretty clear that the effort in the int area was almost the same as the effort for the draft that Mike and I had done earlier. And so eventually it was suggested that those two efforts be merged. And so the new sections in the current draft that includes this merged information is some new sections in the draft. There's issues at layer 2 and below, issues at layer 3 and above, and some optimizations to alleviate the problems, what we call protocol optimizations. And then Warren contributed some text on operational optimizations that are in the draft, and then multi-class considerations for other wireless media, in particular 802.15. So next slide, please. So here's some of the protocol optimizations that are described in the draft. There's a proxy ARP specification for 82.11, and there's proxy neighbor discovery for IPv6 and address registration. By the way, there's also a draft RFC 6775 update that has some specification for proxy neighbor discovery in Ripple-based systems. Important for wireless devices, battery-powered wireless devices, is trying to save power, and the way they do that is by going to sleep for a while, and that can interfere with the proper reception of multicast. For instance, if the access point is trying to send out multicast to the sleeping devices, well, they can wake up, get a packet that doesn't belong to they don't really need it because they're not in that multicast group, and try to go back to sleep. There's also some other IPv6 support in 82.11-2012. And by the way, there's a new 82.11 roll-up coming out, I think soon, like it's almost done. But I'm sure all this will still be in there. One time honored technique is to, well, let's just don't do multicast anyway. If you've only got 2 or 3 receivers locally for the multicast group, you might as well just unicast to both of them, or all 3 of them, or whatever. And it's a matter of arithmetic to figure out when you should stop using unicast and start using multicast to deliver the packets. Yes, question?
Yeah, about that. This is Jake. Section 4.5, I think it was. I would love to see filled out. But sounds like an interesting technique that just had the one sentence that it happens.
I'm sorry. Which
In the draft, the one that's up there.
Okay.
I think it just. I would love to see some elucidation of how that works.
Okay.
I'm not sure if there's a standard for it or what exactly. I didn't find anything obvious, but.
Well, standards, which standard? I guess I think there's actually something in IEEE for that.
Just a reference to the appropriate standards would be
Okay.
great. Yeah.
Thank you. I'll take note of that. And then there's okay, so basically, I think it frequently is just said that in some drafts I've seen, if you want to do multicast, you're allowed to convert it to unicast to all the receivers that are locally. And that, I think, has been considered to be sufficient specification. IEEE has created several approaches for this problem. One of them is called a direct multicast service, which is pretty much that. In other words, instead of blasting it out to everybody, you're directing it to each particular receiver. And then for this problem I mentioned before about multicast not being acknowledged, there's something called groupcast with retries, GCR, which provides a layer 2 acknowledgement for multicast. Next slide, please. So there's some other workarounds that are mentioned, and there's a little bit more about the traffic class idea on the next slide. reliable registration can help. So the whole idea of reliability in multicast over Wi-Fi and 802.15, and maybe even especially 802.15, is problematic because in the case of 15, they all thought this was all the responsibility of the higher layers and never specified it. In the case of .11, unicast was just economically way more important. And so we also could suggest some new approaches to help save battery life. And so try to arrange it to where you don't have to wake up for every multicast packet. That would help a lot. Next slide, please. So I guess it was about a month and a half ago or 2 months ago that I did do the merge, or we did the merge between the nth area document and the Mboned document. But before that, Joel, is Joel here? Joel Jegley? He had read both documents, and his first comment was, there's no need for two different documents. Okay, so we merged the documents. And but he had some other relevant comments as well. What's the audience for the document, and what problems are going to be solved in IETF versus IEEE, and so on. So he asked four specific questions, and these are my answers currently. But this group should decide really what the answers are. So advice to implementers, I think clearly is yes. IEEE, well, IEEE has a lot to do with the specification for the actual layer 2. So the more they know about the problems we're having, or let's say the mindset of IETF, the better job they can do. And so it's not targeted towards IEEE, but they will almost certainly see it. And besides that, there is an IEEE IETF coordination committee that is aware of this draft. Is there any water around here?
I'll go get you some.
Suddenly out of mouth water. Sorry. So we need to have some division of labor between IETF and IEEE. And once this draft progresses and we get more comments on the mailing list, I think it'll be we'll be better able to discuss this. Michael?
Yeah, Michael Abramson. So this is not directly related to this, but I've seen devices where you turn on IGMP snooping, it turns off any other Ethernet multicast. So V6, ISIS doesn't work anymore. Do we have like implementation advice for people implementing those kinds of functionalities? Because they're obviously, so some of them are doing it wrong. Like they turn off they turn off Ethernet multicast, and that's.
I mean, there is an IGMP snooping draft, and it's been a while, but I'm pretty sure it doesn't say turn off everything when you turn this on.
But does it specifically say don't do certain things when it comes to that?
Well, I think the idea is that if your whole city's on fire, you'd rather turn the fire off and lose a few buildings instead. But you're right. This should be done much more effectively to let the applications run and use multicast in an effective way.
Right. So my point was not on this. My point was not specifically for Wi-Fi. This is like a layer 2 switch wired has this problem. I know these devices. So I know plenty of people who, okay, I have to turn off IGMP snooping, otherwise, a lot of other things doesn't work. But this is all about 802. I would say generically. Do we want? Is this another thing that we should work on? This is not specifically for what you're talking about here.
Well, I think that really at the very heart of it are certain things about physics that can't be overcome. And so that's not specific to 802, but my background is a lot more about 802 than I don't know. I know a little bit about LTE and so on, but I know a lot more about that.
Okay. I meant wired versus wireless in IEEE.
Right. So I think that this draft really should concentrate on wireless.
Okay.
And because the main problems that are discussed here and the reason and the motivation for the draft was all wireless. And exactly how it is I mean, anyway, when multicast was developed, or IPv6 was developed assuming multicast, they were well aware of the wired characteristics of multicast.
One more minute.
Okay, well, so next slide, please. Well, I've already touched on most of these, so I don't have to. Oh, one thing I'd like to mention, though, it really would be nice if we could essentially determine what is our goal for multicast performance. Are we going to be satisfied with 5% packet loss, or is 1% required? Does it depend on the application? And what's the latency requirement for delivery of multicast packets? Next slide, please. Oh, question? Overall?
Yes, real quick, in the slide before that, somewhere else, you had at the bottom some question that I think Joel, I think the one before, Joel asked about what should the IETF do? You just glossed over that. It would be really nice if part of the output of the document, maybe not necessarily in the document, but part of that output from the working group is, some recommendation. Is there another work item or something that we should be looking at?
Right.
Either an Mboned or PIM or somewhere else. That would be very nice. Besides just, because I saw the section in there that says, there's some items for discussion. Besides just putting it there, it would be nice for us to take it somewhere where it should be done. It may be here, but somewhere.
Well, I think this is a really great group for us to learn those things. And I don't want to position myself as, in any way major authority on multicast. I know a lot about 802 wireless and so on. But the multicast problems, this group will contribute to make this an effective document.
Thanks.
I guess that's it. Let me just mention one more thing. So there were some comments from Joel that I responded to on the list and did not incorporate the text for those comments and resolutions in the draft. I was waiting to see if there would be more commentary. But after this IETF, and also depending upon any discussion from this presentation, there'll be a new revision of this document available within, let's say, 2 or 3 weeks. Thank you very much.
Great, thank you. Yeah, please,
Who has the
please
blue
come up.
sheet? Blue sheets over there?
Okay, so thank you all. That's Mboned is concluding. PIM is beginning. Are there not separate blue sheets for PIM? Okay. Please sign the blue sheets.
Just put PIM on there too, maybe? What do you
Yeah.
think? I can't remember we've done that.
We've always done separate.
Have we? Okay, let's do separate.
Okay.
Go and ask for new sheets. We could take one of these.
Or do we not have, there's not one. that
Wait,
says
does
PIM?
the,
Okay, thank you, and we'll see you all in Montreal, I guess.
yeah, we need to just get started. I didn't
Yeah,
see any
just-
heading there, but.
We're just gonna write PIM on there too.
Yeah.
I think that's fine.
Yeah.
There's no reason not to.
Nobody left.
It just says.
You got all the slides on there, or?
I do, unless you wanted to go, do you have them go? I have them all up and ready, but do you have the agenda slide? Yeah, go.
Okay,
Yeah.
I have it all too. Okay, so that one's.
Thank you, guys.
But this one, oops. Yeah. Let me get everyone to start that.
So who's been taking minutes? So are you going to stay? Are you okay to continue? Thank you very much. Yeah, okay. And I'll take some notes as well. So we'll combine them. Okay, let's hit it.
Yeah. All right. Okay, so this is the PIM working group. We have a pretty full agenda. Need to ask everyone to be as fast as they can, more or less. Note well, hopefully you've seen this before. This is the agenda. So we're gonna have, we said 20 minutes for the first presentation. If we get a little bit shorter, that'd be great. Then we said roughly 10 minutes for each of the others, but if you can do it in less than 10, that's good because we don't really have time for all of this. I guess as quick as possible, we'll just go through this. So this is just the status of current working group documents. So we have one document being published in a few days. Pim Yang got some comments during ISG evaluation, and there are some young doctor comments that need to be addressed. Multiple upstream requirements. RAD had several comments on that, so waiting for the authors to respond to that. IGMP MLD Yang also got a lot of young doctor comments during the evaluation, so we need the authors to respond to that. PIM explicit tracking isn't moving anywhere, but the author is saying that he will try to do an update for next IETF.
There are new separate blue sheets.
Yeah. Please sign the blue sheets. We have to do separate sheets for Mboned and PIM. We have a working group draft on DR load balancing that was brought back last IETF. So it went to working group last call and went on to the AD a few years ago. There were lots of comments, and no one responded to those comments. And then last IETF, it was presented again with updates. And the question is, what we should do about that draft. There's no presentation today. There's no changes since last IETF. Mike. No, the DR load balancing.
Oh, the first one. Okay, yeah, we don't, I'm not sure.
Yeah.
We can take the list, or I don't know if we need to.
Yeah. So, okay. So as an author,
Who cares?
I would like to ask, if it's possible to do a working group last call soon, whether we can do that on the list, or want to ask what the chairs think.
Okay, real quick, who thinks this is ready for working group last call? The DRLB draft at the top there. Raise your hands if you think it's ready. Even if you're an author, raise your bloody hands. Okay, so we have one person in the room that feels that it's ready. Does anybody think that it's not ready? Okay, and say why.
Security considerations section. There was reference to the NMDA standard. I'm a little confused as to, because there was, I guess there's been some changes in the recommended practices for Yang models. Is that accurate? I'm not really sure. The security considerations section seems really thin. I think we're going to get pushback.
Okay, so please provide comments on the list, and the authors will try to follow up. Okay, thanks.
So just really quick about security and Yang, there's a template somewhere. I don't know where it is, but I can Google it somewhere. That we agreed with security ADs that if we put that in there, they're going to be happy.
All right. Okay, then we have DR improvement draft. No update this meeting, but yes, we need people to please go and read the draft and provide comments. It's been staying there for a long time now, and we really need people to help provide their inputs. Let's see, IGMP MLD Yang. Let's see. Yes, we're waiting for Yang for the authors to respond to the Yang doctor comments. We have MSDP model for Yang. Sorry, Yang model for MSDP. We had a working group last call, and there was hardly any responses. So I guess, I don't know, should we do a new working group last call, or do you think it's not ready, or no one is interested? So I'd say, please, if you care about Yang model for MSDP at all, please make comments on the mailing list, and we'll try to do another last call and see if anyone is responding to that. But we need some responses to move forward.
Justin Dean, just a suggestion. In our working group, we've had a document that wasn't getting a lot of feedback on in last calls, and we asked for an area review, and we got a really great one, and it facilitated moving it forward.
Yeah. All right. Okay, great. Yeah, thanks. That sounds good. Yeah. Okay, cool. And then we have IGMP MLD snooping. Young model. We'll get a presentation on that this meeting. And then we also have this draft on basically how to do, let's see, how to resolve, how to find your PIM neighbor or RPF neighbor if you have an IPv6 next hop and you only have IPv4 PIM neighbors. So that draft hasn't had any changes since last IETF either. The authors believe it's, which includes me, believe it's in a good condition. Just want to see if the working group has anything more that should be added to that draft, but we haven't got any feedback. So Anna, as an offer, I guess I'm wondering, is it ready for last call, or what do we do from here?
Okay, same thing. So who thinks that this draft is ready for a working group last call? Got one hand, two hands. Anybody feel that it's not ready for a working group last call? Okay. Is there a hand? No. So, okay. So we'll take that to the list, of course, but that's kind of a start.
Yeah, the main problem is we need more input. You know, we need a group to be more active. It's like a general issue, but all right. Okay, let's start with the presentations.
Brian.
Let's see. So that, yeah, let's see. There's.
Okay, I'm Brian Adamson. I'm going to talk about kind of multicast routing from the perspective of the mobile ad hoc networking working group. The next slide. Do I need to try?
It's okay. Yeah, we can try to use this. No, that won't work. Okay, I'll do it here.
Basically, a short outline. Going to just have one slide that kind of highlights MANA routing protocols, because this is a PIM working group, so there may not be as much familiarity there, as well as provide some outline of some of the approaches that have been taken to multicast routing in mobile ad hoc networks, and then a little bit on the concept of simplified multicast forwarding, for which there is an experimental RFC, and then some ideas moving forward. And really one of the points of this talk is we've identified that there are definitely some forwarding plane considerations for how you do multicast forwarding and support what's needed for wireless networking, and I'll talk about that a little bit. Next. In a nutshell, we originally had a set of experimental RFCs, which consisted of a proactive link state routing protocol called OLSR, Optimized Link State Routing, as well as a on-demand distance vector protocol, AODV. Many people have heard of the first two, and there were also some other techniques that also made experimental RFC. One of those is a source routing protocol called DSR, Dynamic Source Routing, as well as another proactive protocol called DBRPF. Where we stand in the working group today is the OLSR v2 protocol was captured as a proposed standard in RFC 7181. And one of the things that we did in the working group in the past number of years, decade, is from those original experimental RFCs, we took a little more of an engineering approach and modularized some of the functions of the protocols using what we termed a building blocks approach. And part of that included NHDP and neighborhood discovery protocol, with the idea that that could support different types of routing protocols, as well as a common packet format for signaling, which is known as the packet DB document. And both of those are supporting proposed standards that OLSR v2 uses. In addition to what happened in the MANA working group, there were some other activities in other working groups. There may be some people from here, and I'm less familiar with these, but stuff at Ripple, and there's all out of the lossy low power rural working group. And then there's another effort called Babel, which is also its own working group. And finally, actually the OSPF working group documented some MANA extensions to OSPF. And I think there are 3 experimental RFCs that basically describe 3 different candidates for extending OSPF to work in a more mesh networking type environment. Next. Multicast routing is challenging. Actually, Charlie talked to a lot of the issues, so I won't dwell on those. Another subtle issue is that because I may receive a packet from someone I can hear over here, but need to forward it to a person I hear over here, I may be actually receiving and forwarding a packet out the same wireless interface, which makes reverse path forwarding checks more complicated. And also, the topologies can be really dynamic. So even if you could do some reverse path forwarding check, sometimes you might be better served to treat multicast a little differently because those checks may not always be valid. There were some concepts for multicasts that were been proposed both in some academic papers as well as some old draft internet drafts. Some of these were tethered to the unicast protocols that I described, like there's a multicast AODV draft that was proposed quite a few years ago, as well as a multicast OSR protocol. And then there was a different approach called ODMRP, on-demand multicast routing protocol. And then actually the OSR.org implementation of the OSR protocol actually had a mechanism called basic multicast forwarding. It was not a standalone IP packet forwarding mechanism, but rather an API that an application could register with to submit packets that got flooded over the same backbone that the routing protocol messages got flooded over. So it's sort of like an LSA, opaque LSA thing. Where the MANA working group actually landed is we actually have an experimental RFC entitled Simplified Multicast Forwarding, and the next slide talks about that. Basically, we don't do anything group specific in SMF. We flood multicast packets within a MANA routing area. And just like that basic multicast forwarding that OSR did, it uses the same, it can use the same efficient flooding techniques that are used to help more efficiently disseminate link state information for like a protocol like OSR, except we differentiated because you may want to have different metrics by which you do data flooding versus control plane flooding. And actually there are a number of different relay set algorithms that can be used. And what's interesting about the relay set algorithms is that they actually use neighborhood information only. They don't require any kind of global topology to make to select a backbone. The way they do that is basically you get from your one-hop neighbors, you learn kind of what the two-hop neighborhood is, and there are actually a number of different algorithms for calculating and selecting relays that guarantee that you're going to reach everybody in a domain, and the term is used connecting dominating set because that's basically the subset of nodes in the graph that can reach everybody else from one hop away. In addition to these basic algorithms, ourselves, we've done work looking at some different enhancements to the algorithms using metrics to help overcome the lossy characteristic of some of the layer 2 protocols that we deal with, particularly when it comes to multicast. For example, maybe selecting extra relays beyond that minimum connected dominating set to provide an additional redundancy in transmission to help overcome some of the packet loss that happens. Another little issue is the algorithms kind of are designed to say optimize a current snapshot of topology, but in a mesh network where things are moving dynamically, sometimes it's better to maybe stick with more of a suboptimum relay set in the interest of stability for your data flows, as opposed to always causing the set of relays to flap around quite rapidly. And so these are some enhancements to those relay set algorithms that have been explored. None of those are yet captured in any RFCs, but there are some academic papers out there on it. Next. A couple implementations. I already mentioned the OSRD basic multicast forwarding. We actually at NRL have an open source implementation called NRL SMF, which is a cross-platform user space forwarding daemon. We mostly use it for simplified multicast forwarding, but it can be used for other purposes too. In addition to doing classic flooding, which is also called dumb flooding, where everybody floods each packet, it can be controlled by either an NHDP daemon, such as our OSR protocol, to do relay set selection, or we've also integrated it with the Quagga OSPF with MANA extensions to do relay set selection for more efficient flooding. In SMF, it does the duplicate packet detection, which the next slide I think talks about. Oh, actually, first this where it stands in the world as a user space routing daemon or forwarding daemon. It actually uses various mechanisms, either PCAP, packetecture interface devices, or virtual TUNTAP type interfaces to basically capture or intercept packets coming into the operating system, and from possibly a radio, and then we have an API to interface with the routing daemon to control the relay set selection. One of the things that we've been doing, and this is when we kind of want to get to the end of the talk here, is really talk about, we've been exploring now, how do we construct a forwarding information base that can support the needs of simplified multicast flooding, as well as possible multicast routing mechanisms that are group specific that we maybe layer on top of the SMF flooding. Next slide. And that's kind of what this slide talks to. We actually, in the MANA working group, had a couple drafts that were presented a couple years ago, and they're both expired. One was on an enhancement to that ODMRP protocol that also included support for asymmetries, where I may have a link that's a broadcast transmit only interface, where I may have other interfaces that I'm receiving on, so I have non-reciprocal connectivity. And this document describes techniques for constructing a multicast routing tree or mesh. It's more of a mesh than a tree, over topologies with those non-reciprocal links. Also, we've had a proposal for a concept called elastic multicast, which is more of a flow-based multicast routing protocol. It starts with the same flooding mesh that SMF uses, whether it's classical flooding or one that uses the efficient flooding via relay sets. And then it actually uses acknowledgments from downstream nodes, i.e. nodes that have joined groups or who have downstream neighbors who have joined groups, to keep a higher rate of multicast forwarding active from a specific source. So when we say flow, it's really like a 5-tuple description. Typically, you would join a group, which would be a star G or even a source SSM group, and then that would basically detect packets that were flooded at a low rate and reactivate them for higher rate flooding, like say an IPTV flow or something like that. So that only high rate flooding occurs for flows that there are actually people in the wireless network interested in, and would only go to the parts of the network where there is actually interest in that. In addition to using the actual low rate flooding of packets to sort of advertise or announce flows, we've also have a proposal to have an advertisement message, which is kind of like a route request for a multicast group, more similar to ODMRP. You basically announce a packet describing a flow, a source group tuple, for example, and then downstream nodes would acknowledge that to then start activating forwarding of the flow through a subset of the SMF mesh. What I point out too, that can actually be used to support gateways to FEM routers, because you could have basically a gateway device use that advertisement message to advertise its presence to the MANA mesh. Next slide. Keep things going forward. Again, the main thing that we use to enable safe flooding in a network is duplicate packet detection. And that's one of the main aspects of the simplified multicast forwarding RFC, is to describe the semantics for how you do duplicate packet detection for IPv4 and IPv6 traffic. Essentially, in our LSMF implementation, to do duplicate packet detection, we already keep a state on a kind of a per flow basis to help reduce false duplicates. The specification describes a combination of hash-based or identifier-based duplicate packet detection. And for V6, it even specifies a header extension that can be used to apply a specific unique identifier to IPv6 packets. We keep a limited history or a window of duplicate packet detection per flow. It's configurable in our implementation. And then, because we already had that, building a concept like elastic multicast on top of the SMF forwarding engine was relatively straightforward. Did have some additional things you need to detect when you flows, because now you're actually concerned about group information, whereas enough that it will care about that. I also point out that in addition to multicast protocols, on-demand protocols like AODV kind of have a similar need. It's not often easy to deploy an AODV protocol on existing internet protocol hosts because of this concept of on-demand routing. You kind of need to know when a packet for a specific source destination comes into play so that route requests can be activated. There's probably similar implementations to what we've done with SMF for that, but the idea would be if we do build a forwarding information base that's sort of a MAN-A multicast, it could also possibly have some support for similar concepts for unicast routing as well. Next slide. As an example, when looking at that in our own implementation, for inspiration, we went and looked at the Zork source code. And basically, that's the data structure in the mroutd header file. Next slide kind of shows possibly places where we would add additional state variables to keep track of things like duplicate packet detection and other stuff, depending on what the protocol needs, like Elastic Multicast does a little more packet counting for flows and that kind of thing to decide when to trigger those acknowledgement messages that I described. Next slide. Basically, a mirror of that mroutd is we had the basic, in our SMF implementation, a concept we called interface associations, where basically when a packet came in an inbound interface, you maintain both duplicate packet detection state as well as the type of flooding algorithm that was being used on a pairwise interface association basis. Next slide. And we augmented that for a protocol like Elastic Multicast by simply extending that and adding more state variables to this. And this is this isn't showing you the details of it, but this is where at least we're actively looking at how can we build a forwarding information base for MAN-A multicast that can be applied in a general way, both to support things like Elastic Multicast that we're working on now, as well as potentially other protocols moving forward. Next slide. We can kind of skip this one in the interest of time. Conclusion, just in a summary, we think that mobile ad hoc networking multicast has some additional considerations as compared to more conventional wireline multicast protocols. And we think that there's a potential for some type of common fib and supporting control plane interface to support these protocols. I think the MAN-A working group was, and Justin's the MAN-A chair, can talk to that a little better than I, chartered to develop a fib, but moving forward with MAN-A, I think the idea is maybe to talk to other working groups to see if there's some common goals that people have interest in.
Justin Dean, chair of the MAN-A working group. We brought this presentation here because this is something we're chartered to do, is to work on a forwarding information base for MAN-A. The MAN-A working group has had less and less participation, so we're looking for more people to participate, and we think it has a larger can have a larger impact than just MAN-A, because we have up there Babel and Roll, and they all have the possibility of doing multicast in these wireless networks, and we wanted to make a way that there's a simple interface that they can all kind of talk down to control the multicast that could be disseminated. So you could end up with different capabilities for different purposes for multicast, and we thought PIM might be the right place to do this work instead of in just the MAN-A, so that it gets put out to the wider community. So with that being said, we are looking for people who may be interested in working on this and input from this group and others. That's all I have to say there.
Yeah, sorry. Yeah, so this is the right group. Thank you for coming. As far as discussing this on the email list, do you think it would be practical to do it on your list and our list? Or do you want to have a separate list just among certain participants?
Yeah, I think that would be useful to do it on both. We are going to have a talk, me and my co-chair and Alvaro, about where MAN-A is heading later this week. So we'll have a better understanding of what of where we're going to go after that.
Yeah.
But yes, I think we should have it within the PIM group.
I would second the idea of having on both lists because you'll maybe capture some new subscribers and that kind of thing.
Yeah,
true. That aren't on both lists. Right? Charlie?
I'm Charlie Perkins. So SMF was really developed in response to the need for a efficient flooding protocol.
Yeah.
And so it really tries to include the whole network
Right.
across a connected dominating set. So this is exactly what's needed. As you mentioned, it's tough to deal with relay points that are mobile and breaking their neighborhoods up and so on. But I just was wondering, how appropriate is it for actual multicast groups that the membership may only be a small percentage of the total number of devices in the network?
Right. So that's exactly part of the motivation for something like Elastic Multicast, which prunes down that flooding mesh to just the subset of relays needed to service those sparse members. We've even done a little bit of unicast support of the Elastic Multicast idea. Right now, we have an experimental implementation of it. I think it's possible. We've done an internet draft before that describes very high level the acking mechanism. I think there's a better document that could be written if we got people interested in the working groups in doing that. And we also have some ongoing research where we're looking at in those acknowledgement messages embedding. We have an idea of a confidence and a quality coefficients to help maybe more intelligently decide if we need to have some redundancy in the relays to provide more reliable multicast forwarding within a very lossy wireless area, and potentially even to use that information to construct network coding forwarding strategies within it, which is not something that's ready for prime time here, but those are kind of the forward things that we're investigating.
What's the motivation for the term elastic? I mean, somehow.
Yeah, it was just a term picked because the idea is you start with a mesh, and then as kind of like a rubber band, the acknowledgements kind of expand and contract that flooding mesh. It's not really a tree because it's really built on top of the relay set mesh of flooding that you have. So it's more of a pretty sounding phrase than a really logical.
So as working group chair of the Mboned group, Justin Dean again, I think Elastic Multicast is a driver for the work that would be being done in the FIB.
Yeah.
You would want the FIB to support something like Elastic Multicast, but Elastic Multicast isn't the only thing that would use it.
Yeah, for example, like Moody Marquee that we're
right. So depending on your deployment, if it is more static, you might want to use something different to control the FIB. But I think the main point is that we get the FIB right for wireless multicast so that you can control what's being flooded where by different algorithms. Elastic Multicast being the one that is driving us right now, but there would be others as well. We want to capture that. We don't want to work so that we have a standalone protocol and it does what it does and nothing else would work with it. We think that there's more value in building up an engineering solution so that other protocols could use a FIB.
Jay Colin, just for clarification, Mike, you're saying, is this a suggestion to recharter the group to support the needs? Okay, so it's more a suggestion to figure out how to express these needs within PIM. Is that the idea?
The idea is to support Mboned with multicast expertise as they develop the FIB.
I see. Okay, thank you.
Mboned currently is chartered to do this work. So, and we're looking for more participation and interest from people who know multicast.
Any further questions? Okay, thank you.
Thank you very much.
All right, we need to move on here.
Okay, I will give a quick introduction for the IGMP snooping young model. From the last IETF meeting, we have update for the draft for two things. And the first one, next slide. Okay. the first thing is that we make the IGP snooping instance under the brief view and the VLAN view, and also under the L2VPN view. And we deleted from the interface reference. And also the second thing is that, next slide. Next. We augmented the interface model to configure the IGP and Emily snooping, and also the statistics of the protocol. And the next slide. That's all. And next. And we think the young model has been stable and ready for the young doctor's review. And so we can ready for the working group last call.
Jay Collin, the security considerations document on this one, I think, also does not follow the recommended template yet for Yang. So maybe update that and then.
Thank you. Awesome. Thank you, Yisung. Okay, so now we have 6 individual drafts being presented to us. We didn't have several PIM drafts presented this time for the sake of time. So Zay Chen, am I saying your name right? You're up next. Yep, very good. And this may be blasphemy, but we're probably going to go over the noon cutoff time. So at that time, feel free to leave, but we may just keep going, and it's going to be recorded. So,
but please, yeah.
But be
try to be
brief.
quick.
The adverse service is going to terminate the
Yeah.
Okay, that's fine.
It's try to
fine.
finish close to
That's
me.
fine.
Yeah.
And we can keep on going with the notes if you guys need
Okay.
to go. Get it.
Good morning, everyone. I'm Zhechen from Huawei, and the author Mboned cannot come to London for some reasons, so I'm going to present this slides. And this is a very initial work on PIM-SM protocol, just submitted after the Singapore meeting. And this is the problem description as defined in current standards. Join messages are multicast packets, and the destination address of these packets are well-known multicast address called all PIM routers, and the TTL of the packets should be set to 1. And a PIM router would compare unicast upstream neighbor address carried in the message with the address to itself. If these two addresses are same, and the message will be processed. So the problem is, as long as there are one router in the network cannot support PIM, and the join message will be discarded, as shown in the example below. If the router X does not support PIM-SM, the join message from DR3 and DR4 will be discarded. So next slide. Next slide. Okay, this is the big picture of the solution. The core idea of the solution is to put an unicast IP address into the join message. The unicast address is the address of the RP point or the source. And the routers in the network could be PIM routers or legacy IP routers. For PIM routers, it just involves an SAL policy or similar like that to capture the join message and process it. For legacy IP routers, they just forward the join message based on the destination address. Next slide. These are some details. Neighbor relationship between PIM routers will no longer be maintained, and the join point messages will no longer be multicast with TTL1. They will be unicast as below. The destination address of the join point message should be the RP address or the address of the source. The source address of the join point message should be the address of the join or point router. Next slide. This is the processing of the join messages. Join messages could be received by PIM routers through ACL or similar means. They could also be received by the destination of the messages. Next slide. And there is one change to the packet format. If a SPT is being joined or point, there will be no joined point source address field in the message, and the number of joined source in the message is 1. Next slide. So because this is a very initial work, we need more reviews and comments. That's all. Okay. Any question?
Hi, Jake Holland. Do you see any advantage in this over establishing a GRE tunnel and making a PIM session over that?
You mean the reverse tunnel for data packet?
I mean that this work proposes to sort of establish an ACL-based relationship between two PIM routers that are not directly connected. So if you're doing this, why not set up a GRE tunnel instead? And just run PIM without modification.
But you should pre-configure the tunnel, right? But not just sending a message with unicast address. We have to configure the network with many tunnels.
Right. So that same would be true for ACL, right?
Yeah, we are going to avoid so many configurations.
Okay.
Maybe some automated tunneling, so you don't have to configure the tunnels, could be useful.
Mankamna Misra from Cisco. So my question is, do you have this unicast packet only for RP or even it is for SSM case?
Sorry?
So in case of SSM join, where you are directly joined to the source.
Yeah.
So you are going to do the same mechanism till source, or it's only for the RP?
Yeah, that's the same mechanism.
Okay.
Hey, Ice from Cisco. I've got two questions. So about sending the join, how do R2 or R1 know the address of the RP? I guess they can know X is not PIM capable, but how do you determine what the next PIM router is you want to send your join to?
Yeah.
How do you do that?
Currently, we haven't considered this.
Okay. And when the RP sends the multicast packet to R1 and R2, I assume it's sent as unicast or it's tunnels?
Yeah, they are unicast tunnels.
Okay, so you convert the multicast on the RP to unicast, and then it's received by R1 as unicast.
Yeah. Sorry, I can't answer the
Maybe
question,
if you
but maybe you
details
can
would be
feedback to
sorted
the
out.
author and send you an email.
Okay, yeah, so please send comments on the mailing list and we can discuss it there in more detail.
Thank you. Say so.
So what's the...
Greg Mursky.
Yeah, I don't have the agenda in front of me.
The BFD, yeah, you got it. Yeah, that's right.
Okay, so we're presenting use of BFD for multi-point networks, or for short, point-to-multipoint BFD. In the case of PMSM on a shared segment. Okay. So, as discussed, that proposed that to have a designated router which takes the special role responsibility of for directly attached hosts, that the only DR sends the join, and the other routers, they just listen. The problem in this situation would be is that if something happens to DR, then the other router, which is capable of taking on DR role, will find it out by default in 105 seconds. So even if we will change that default setting to the minimum, so that hello packets to be sent every second, then it still will be single-digit seconds, which is significant impact on the services that are running over the multicast infrastructure. So what we're proposing is that the DR to use point-to-multipoint BFD and become a root of point-to-multipoint BFD, and other nodes on the same shared segment, PMSM nodes, to be leaves and listen to that. So that will allow other nodes to detect their problem with the DR in sub-second interval. And because point-to-multipoint BFD uses demand mode, so it's a unicast distribution. So the leaves don't send messages to the root. So thus, it's very nice fit with this scenario. Next. Okay. Yes.
Hey, Greg. One of the reasons for
you need to announce yourself.
Hey, Andrew Dolgan, Nokia. One of the reasons for those timers to be what they are is for the network to converge. Have you tried doing this in a real network and see what instability you're going to cause? Because that continuously is an issue. Like there's a lot of state. It may look nicely on a slide with 4 routers, but if you have multiple routers and you start seeing failures, and if you start re-establishing the tree too fast, you're going to have instability in a network.
Well, actually, when
bad things happen.
Yeah, when we work on this proposal, we had in consideration the other proposal that's already a working group document. It's a DR improvement that suggests to have a BDR. So the BDR already has a state. It just doesn't act on it. So the BDR can detect the DR is out and then take immediately the role of DR. But again, if we look at only this scenario that we have only 2 routers on a segment, then some will say, okay, why do you use point-to-multipoint BFD when point-to-point will suffice? First, point-to-point is bidirectional, and DR is not really interested in the state of BDR. So that will be an overhead. At the same time, and point-to-multipoint will definitely work for the case of 2. And another is that, well, we can imagine the situation when you have more than 2 PMSM nodes on a shared segment, and then again, point-to-multipoint BFD works seamlessly there.
Andrew again. I have, maybe it's a philosophical comment, but you know, PIM is great when it's left alone the way it was intended to work. And if we're gonna try to make a Fiat into Ferrari, that's not gonna. That Fiat will fall apart.
Yeah, I understand that even pig will fly with enough thrust, but it will probably fall apart in the process. Again, this is a proposal. It's that open for the discussion. We appreciate the comments and thank you for your insight. If it seems that sub-second detection is too fast, again, nothing precludes to make it slower, but still faster than 105 seconds. Again, use of BFD does not mandate how fast you detect. It only tells us that there is a way of being more flexible than existing control plane detection.
absolutely agree. I've seen network that 105 was too fast. That's why I'm worried about going to much, because the whole thing is, if we want to have a solution for a faster convergence of layers, and I'm more than open to having it, but then we have to make it really well defined in a scope of what's the scope, what's the size, what are the things, before somebody takes a year from now a draft that may become an RFC, reads through it, and expect that to work in real world in a infinite scale of the network. So that's my concern. I'm not saying that this cannot be done. Everything can be done, as you noticed, but everything has its scale and an environment it can be deployed in.
Right. But again, what I wanted to reiterate is that we put the scope on this proposal only for the shared segments. So it's not that we are envisioning or suggesting to use point-to-multipoint BFD from RP throughout the domain. But I appreciate the input, and let's keep this discussion going on the list.
Yeah, yeah.
So,
sorry, can I just make one comment too, as a participant? Yeah, so there are several implementations doing BFD with PIM today, but they do I think typically like a full mesh of BFD peerings. So this would be more scalable than that,
yeah,
right?
Thank you. Yeah.
And we have a Yang model draft for PIM that also actually has some BFD parameters in the Yang model. Because there are several implementations doing this, and maybe it could be helpful if you look at that.
Actually, it's a very good point, because I participate in BFD Yang model, but BFD Yang model does not include point-to-multipoint, because we are finalizing base point-to-multipoint BFD specification, and when it's done, then we can go back to the Yang model and see how we need to adjust.
Yeah. By the way, sorry, I think we maybe remove the BFD parts of the PIM model because it's in the BFD specific model.
Yeah, that's what we suggested to protocols, is that use mount of BFD. Okay, so what we're proposing not only to use point-to-multipoint BFD in this scenario, but we propose to have an optional TLV in a hello packet to use DR to bootstrap their session. Difference between point-to-multipoint BFD and the regular BFD, that there is no three-way handshake process. So thus, there needs to be some out of band, or whether it's a control plane or management plane, that will inform leaves of the discriminator that the root is using. So that's what we're proposing, this optional TLV for, that to be included in a hello message, so the DR will advertise the discriminator that being assigned to this point-to-multipoint BFD session. And then when it's a root, it should use the same IP address as a source IP address as it uses in PIM-SM hello message. So can we go? Yeah. So that's a very simple extension. It needs to have type, length, and my discriminator. My discriminator is a 32-bit long unsigned. So that's it, and I appreciate comments, and thank you, Andrew. And I think that we can have one more comment, or just take it to the list.
Okay, one more comment if there is one. Yeah. All right, we'll discuss the list. I think I'll have some comments myself too. So thanks. I think I'm next.
Okay.
I think I should stand up there because it's the video.
I'll forward your slides.
Yeah. All right. So just wrote this draft a few weeks ago about reserved bits in PIM. So I was discussing with Alvaro when we did, he was reviewing some other PIM documents, and we realized that there are some minor issues. Next slide, please. So it turns out that several PIM message types are using reserved bits from the common PIM header, but they don't update the base PIM RFC, and there's nothing really saying whether those bits are supposed to be per message type or if they're kind of like common for all PIM messages. So one thing this draft does is basically point out that each message type is free to use the reserved bits in its own way. And that's already being done where PIM Binder, for instance, is using 4 of the bits to indicate what kind of DF messages they're sending, while some of the same bit positions, or one of the same bit positions, is used for no forward in BSR. So there's already precedence for this. So also by using the bits per message type, we basically can do more with those bits that we have. The other thing the draft proposes is how to extend the PIM message space, because we only have 16 message types and we already have used 14 of them, or 13 of them. Next slide, please. So what it's proposing is that we use type 15 to extend the space. It's similar to what was done with DF messages for Binder. It basically says we can use some of the bits, like 4 of the bits, over here, 4 of the reserved bits as a subtype. So basically that means that we can have 16 additional messages. So existing implementations, they would just see type 15 and they would ignore it. If you support any of the new message types, you would have to implement type 15 and know how to look into the subtype field for additional type specification. One thing we could consider is we could maybe make it wider. If you think we might run out of those 16 additional types, maybe we could use one of the reserved bits and actually have up to 256 possible types. What it means, though, is that any few messages that are using those types would have to maybe include their own reserved field or something if they want to have some additional reserved bits for the specific type. Next slide, please.
I don't think there is.
Okay. Yeah. So basically, the question is, do you think it's worth extending the type space? Is it done in a useful way? And hopefully you agree that it's good to document how we use these reserved bits. And it also, by the way, defines IANA registry showing which bits are used by which messages for which purpose.
So, dumb question. I'm Charlie Perkins from Future Way. But can you show the last slide again? Yeah, so if you want to get a lot more subtypes, you could make types 13, 14, and 15 all use that subtype field, then you get 48 more.
Yeah.
That'll do for a while.
Right. Yeah, actually, if you guys like this idea, then there's no reason not to do that. I agree. Yeah, it's a good point. Yeah. So currently we have no new drafts, requesting a new type, at least no working group drafts, but there's a couple of things in this meeting and potential future ideas. Yeah. All right. I guess ask for comments on the list. Yeah, please read the drafts and provide comments, and yeah, this might help us, be able to do more future work if we need more message types. Okay, thanks.
Thank you. All right, Jingrong, you're up.
Good morning, everyone. I'm Jin Rong from Huawei, China. I need this piece of paper to help me express.
That was the beer extension.
That's right.
Yeah. First of all, I want to do a vote. How many people in this room know about beer? Please raise your hand. Oh, about 15. Okay, thank you. Thank you. So before this draft is in fact a protocol draft to support scenario draft that I just read in beer. Before the introduction of the peer extension, I want to introduce some background about beer. Beer is an alternative multicast by using a multicast specific beer header. It is defined in 2 RFC. The first line, 2 RFC. Considering the transition from NGM VPN to beer, I have been reading a draft to run beer on a multicast tree. So one of the multicast tree is built by PIM. This is what this draft want to do. To build a multicast tree with some beer related information to support forwarding many multicast flow using a single tree, while not wasting any link bandwidth. That is to say, multicast is always replicated on demand. So this is the compilation of 2 parts. The first part is a multicast specific encapsulation we called beer header, and the second part is a multicast specific label we called beer label, and the second part is the well-known PIM protocol, which is a multicast specific protocol. So next page, please.
That's right.
In this picture, we build one tree. A is the root of the tree. D, E, and F are the 3 leaves of the tree. Now PIM need to build the tree. It seems to be easy, right? PIM build a tree, easy, right? So then the data plan forwarding began. When A receive a packet, it imposes a beer header to the packet with a bit string 0101 to tell every node in the network who received this packet that it wants to go to D and E. So D and E will get the packet, but F will never get this packet because the bit string is 0101. So this is the tree-based beer. It is a tree with beer information to support the forwarding procedure. Then how can we build a tree with beer information? Come to the next page.
One question here. So
sorry, maybe listening English is hard for me. So I want to present the whole slide. Can you ask a question after that?
Actually, why don't you?
Thank you.
Why don't you go ahead and answer the question right now? But he's not going to probably be able to answer it because he may not be able to understand you.
okay. So my question was: is it complete beer domain, or it is a hybrid of PIM and beer, or it's complete PIM? The picture which you're showing.
Okay, it's all a beer domain, while at the same time it is a PIM domain. We can say it is a single, like a single IGP area. So the next page we will introduce. We will build the tree with beer information. The principle is when a downstream node send a PIM join to its upstream node, it includes an extra join attribute, which we called beer join attribute. It includes a subfield called FBM, forwarding bit mask. For example, when D send to C a PIM join, it include a FBM of 0001, and C send to B with a forwarding bit mask 0011 and B sent to A with a bit string 0111. So this is the main principle of the PIM extension. Add a join attribute called beer join attribute. Come to the next page.
Okay, hold on just a second.
This is the beer join attribute.
Paging wrong, just hold on just a second.
Whom Golinok here. Just again, to understand this, to this slide, are you trying to say that both beer and PIM are signaled at the same time throughout the network? Is this like PIM over beer or vice versa, or there are two separate trees?
Okay, it's a combination of PIM and beer, in fact, combination.
Okay.
So in the first slide, I have said it is a combination of three parts. PIM is a multicast specific protocol. Beer is a multicast specific encapsulation. One is the protocol in control plane, and one is the encapsulation in data plane. We combine these two.
So basically, PIM will override will write beer. That's basically PIM will go over beer. Is that's what you're saying, right?
PIM. Pardon?
Yeah.
Andrew Logan, it's okay. I actually read it. It looks to me like a PIM signaling of beer. Instead of putting apart the draft, I would highly recommend you read use cases for beer. You read architecture for beer. You understand why beer came to life, and then come to a conclusion about your draft.
Yeah,
you want a use case or scenario, right?
Yeah, so we need to move on, and he's going to be presenting this in beer as well, and you guys can have at it. But the basic idea is he's here because he's proposing extensions to PIM to allow you to build beer forwarding trees in the data plane. So just let him continue, and we got to get going.
Yeah, just maybe 2 more minutes.
2 more minutes. Yeah, quick. Yeah.
Okay. Come on, this. This is the beer join attribute. And the next page is a hello PIM, hello option extension for beer. Skip, next page. Okay. So that's it. An extension to beer to build a tree with beer information. Remember that the most important is the beer join attribute, which includes an FBM. When PIM join message are sent hop by hop toward the root of the tree. And one more thing, the scenario draft will be presented tomorrow afternoon. That is the use case or scenario draft. This draft is in fact a protocol draft which support that use case or support that scenario. We called, I have introduced. I am focusing on a transition, beer transition from traditional NGM VPN. So PIM is one of the protocol used in traditional NGM VPN. So this is the scenario.
Okay. Thank you. Good.
Thank you.
Yeah, good. And now, Mankamana.
So Mankamana Mishra from Cisco Systems. So I'm presenting this for one of my colleagues. He couldn't come here to present this. Next slide.
Yeah.
We have only few slides. So what was the motivation behind this draft was the PIM null register packet. So today I think we send it individual packet per source, and there were a couple of customers who were having complaint about polythene is dropping the packet at the RP because of there were multiple source active on their network, and there are many more protocols they already are doing. Basically, they are packaging multiple packets together and sending it. So that's exactly what we are proposing here in this draft, that multiple null register can be packed in single register and send it to RP. And it's very small draft, and there are a couple of factors which we have taken care, because one of the most difficult part was that how you are going to say that which all null register packets need to be merged together. So it could be timer based, because even if, let's say, your packets are going every 60 seconds, but if we are going to merge a couple of them and some of them are reaching within 40 seconds, so it might not matter much. So we would request you to give a comment and review this draft.
Yes, one more slide here.
Yeah, so the advantage is basically in the network, we are reducing the register packets and better control plane utilization.
No, I don't think so. But they also need to resolve that. Is there anything that we need to ask of the working group? This,
Yeah, I guess. Yeah, please. Please read. If you don't have any comments now, please read the draft and provide comments on the mailing list. Yeah. Okay. I'll do the last one.
Thank you.
Okay, thanks. Yeah, I need your help.
Okay, last presentation right here. Thank you.
Yeah, so this is about reliable PIM registers. It was a proposal that was actually presented here maybe a couple of years ago, and there is some new interest in looking at this now. Actually, some of the reasons to look into this is the same as the previous draft. Normally with PIM registers, you have to do soft state, you send registers every 60 seconds. If you have thousands of S, Gs, it's like thousands of messages. And if one or a few of those get dropped, you still end up doing data registers, which just makes things even worse. So the idea with both the previous draft and this is to come up with some solution for this. What's special about this is to make it reliable and basically make registers hard state. Next slide, please. So some of the motivation why this kind of came back now is, one thing is we're talking about deprecating MSDP for interdomain use. The only other use for MSDP really is Anycast RP. And we also have a PIM-based Anycast RP solution. The problem with the PIM-based one is that it's soft state again. MSDP is kind of nice in some way because it uses TCP, so it's hard state. So some of the idea here is, do we really need MSDP? Perhaps we can do reliable registers over TCP with PIM instead. We already have PIM port, which is reliably sending joint prune messages over TCP, and maybe we can extend that to also send register messages. And let's see, probably next slide. So yeah, I kind of said this already today. Today we have to send individual messages for every S, G, and then you have to send a register stop to act that. And you're in trouble if you start losing some of those messages. One solution could maybe be the previous draft, is to pack multiple registers together. Another solution is what I'm presenting now, which is to make this hard state. So we only send a single single register message when the source becomes active, and you just send a single withdrawal or whatever when the source goes away. So there's no periodic state anymore. Let's see, next slide. Let's move on. Yeah, so the idea is to extend import to send registers. Next slide. So one issue is that import uses hellos to negotiate that you support the mechanism and so on. So this draft has some talk about how to do that between first hop and RP. But next slide. Next slide. Yeah, so this is what I just said about you announce the initial source and then you withdraw it when it becomes inactive. Next slide. So this could be used for registers between the first hop and RP, but also between RPs and then any cost RP set. So one thing is MSCP has some policies for how to do like a mesh group and what sources to announce and stuff like that. If you want to use something like this for that, you may have to add some policies and stuff also to this mechanism. Next slide. Yeah, so you only need support really on RP and first hop routers, which means all first hop routers that you, well, you don't necessarily need this on all first hop routers, but at least to take advantage of it, obviously the first hop router needs to support it, plus the RP that it's speaking to. Next slide. Next slide. Okay, so basically, you would like input on this, please read the draft, let us know if this is a good idea. One thing to consider is, do we need something better than today for registers? Would the register packing draft be what we need to solve this, or do we need something like this, or maybe we need both drafts? They are a little bit different, it solves slightly different problems. But basically, please read the draft and let us know what you think. Please give comments on the list. Or if you have a comment right now, that's okay too. All right.
Thank you. All right. Not too bad, actually. Very good. Thank you for taking the notes. Thank you for coming, and I think we're done. Well done. What's that?
Okay, that's great.
Okay.
Yeah, just, I guess, leave them there and we'll copy them out.
Thank
from
you.
there.
Thank you.
Thank you. Yeah. But yeah, I'm interested in the my network and my network.
We've been going through it for a while now.
Yeah.
And everyone was focused on the unicast routing for the longest time while we were doing experimental SMF stuff, and we've had good success around doing that. We did restart to do the multicast work, but then the unicast protocols got standardized. Those people moved on. The people who were doing other interface radio and router stuff. And people were interested in the multicast problem. So I really think there's good work to be done there. I mean, you did was find like stuff. It works. It's fun. You have really good stuff. I really think you have a wider range.